All right, so everybody, as Jim mentioned, I am an outbound product manager at Google Cloud, sitting across the portfolio of data analytics products. And so I'm not tied to a specific product like BigQuery or Dataproc. My team and I really sit kind of across the entire portfolio. Some of the work that I've been doing in the last year has been thought leadership content in terms of data strategy, product strategy, portfolio strategy. And we've been looking a lot at solutions building our solutions built on top of our portfolio of products that meet some of these more complicated data architectures. So I figured today I would pontificate at you a little bit about what we've been seeing in the industry, give you a bit of a breakdown in terms of what we're seeing as insofar as challenges, give you a history lesson on kind of how we've gotten to where we are, and then talk through a couple of the data architectures that we're starting to see more and more of. I promise there won't be too many shameless plugs in terms of Google products, but they do make an appearance here and there. So, it comes with the territory, I guess. And then the closing thoughts are really around considerations in determining a data strategy. So yeah, let's just dive right in. So first of all, why should you care about data? Really for years, data was considered kind of a byproduct of applications. And it was really almost like a liability. It was treated like this toxic waste that came out of various systems that weighed down the organization. Other than data that you needed for very operational transactional tasks, anything that was a byproduct of the systems was like, well, if it doesn't really help us, optimize our speed of delivery, and if it doesn't answer a couple of known KPIs, then we don't really know what to do with it. So it was really kind of treated as a single point in time data that was super important. And it wasn't really until we started thinking about additional analytics or exploration of data did it really become important. And for a long time, data felt like, okay, cool, we have this stuff. At some point, we should probably do something with it, but we're just going to kind of shove it over here until we have an idea. And at some point, kind of in the last 20 years, data became really, really important, but nobody really knew what to do with it at all. So the approach really became, all right, we got to collect all of the data. We have no idea where it's going to go or what we're going to do with it, but it's going to drive us to profit. And to some extent, we're sort of still there for a lot of companies, and nobody really knows what phase 2 is. So the good news is that companies across industries have realized that we're all sort of in this same scenario, and that to compete in a very fast-moving, fast-transforming, digital world, everybody needs to become a data company, or every company needs to become a data company. But there are still a lot of difficulties getting in the way of, first of all, collecting data in a way that makes sense and using data and becoming AI driven. Everyone wants to build an AI driven, data driven, innovative company. But if you look at the data, really only about 10% of organizations are able to monetize that or have some sort of financial gain. And a couple of reasons, there are kind of 3 major challenges that are driving that. So, first of all, data is no longer small. There's such thing as small data anymore. And arguably there's no such thing as big data anymore. The fact of the matter is data is just incredibly unpredictable. I mean, the volumes are off the chart. We're, in terms of our strategy and our planning within my organization, we're not even really talking about terabytes anymore. And petabytes are almost seen as small. We're talking exabytes, and in the next year or two, we're going to be talking zettabytes. So huge volumes of data, but it's really not just the volume or that rate of change and that growth. It's that data is coming in all shapes and forms and speeds and sources, frequencies. We're talking structured, unstructured data. You've got tabular data. You've got IoT, device data. You've got video and images and sound. It's just kind of all different types of data coming in from 1,000 different sources. Some of that is coming in real time. Some of that is coming in batch, micro batch. And data is really across clouds and across systems. If you look at a lot of the consolidation that we've seen in various industries, every company and every line of business, every team practically has their own tech stack that they're working with. And in times of acquisition, a new company comes in, they have a whole different tech stack that needs to be incorporated. So you get this kind of proliferation of tech stacks that are don't necessarily make sense together, and you have to try to balance all of those. But data is big, data is multi-format, it's highly, highly unpredictable. And data is, kind of becoming limitless in some respects. The second challenge is that the ways that we work with data really continue to expand. So gone are the days where, when you're thinking about business data or analytics, it's just some analyst in a room, type in SQL. There are far more workloads that need to be enabled here. For AI-driven companies, anyone who wants to do data science or machine learning models, mostly there are separate applications for that. You need a more programmatic approach to huge volumes of data. SQL just doesn't really cut it. And there are more and more data-driven applications. So it's not just a database or a BI tool that's interacting with structured data. We're seeing a whole lot more in terms of the size and scope of data. The ways that we need to interact with the data are changing as well. And that kind of brings me to the third challenge, which is there's really no such thing as a data worker anymore, or rather everyone is a data worker. So, a lot of times, I guess, about 20 years ago, I would think of data engineering or data analysts. You have a set few folks at a company who were the ones who interacted with data, and those were like the data people. But really, if you think about it, looking around the retail floor at a shop, everyone has a little handheld device, point of sale. Maybe they get alerts on inventory stockouts, or, alerts from the boss saying that it's time to take their break. There's a lot of data that comes in real time that's very actionable data that everyone is interacting with, whether it's someone on, the manufacturing factory floor, whether it's somebody who's in the C-suite. Everyone does interact with data to some extent, whether they're a producer or a consumer. And everyone has different tools that they need to interact with the data. So data really does need to reach everyone, and that reach is sort of becoming limitless. And so what kind of needs to happen for a lot of companies is that, instead of thinking about data as this liability, this sort of toxic sludge that needs to be stored someplace until someone can figure out how to get rid of it, data should be, and quite frequently is now treated as an asset. So that can even go so far as creating products, data products that can be another line of business. But at the very least, within an organization, data can be and should be a shareable asset. And just one note on that in terms of the sharing, a data point that we actually have from BigQuery is that in a recent seven-day period, over 4,500 organizations shared 250 petabytes of data. And that's not even within teams, that's just cross organizations. So there's a massive amount of data sharing that's already happening, and that's only going to grow, so long as we have the right tools for people to use data and access it as they need to. So, if you kind of bring together these three challenges, they have had some significant impacts in terms of the tech stack, in terms of the way that companies have been interacting with data. Thinking back to companies getting acquired or teams starting to think about different data sources that need to be added to what they have, what we've seen over time is a proliferation of copies of data. Within an organization, say you're not getting the support that you need from central IT, maybe you build out your own infrastructure, kind of go off-piste, start to pull in third-party data sources. Well, now you have multiple systems, right? You've got additional data copies. It becomes a governance nightmare. It's hard to figure out the lineage of that data, kind of the provenance of where everything came from. And you end up with more and more data silos kind of as this whole thing grows. So any of those very tactical decisions about, hey, I don't have the data that I need to do this particular task at this point in time, kind of downstream additively turn into operational issues, cost issues, lower productivity in terms of the teams that have to manage all of these systems, and just, overarching additional tech debt that we all have to deal with. So why are we in this situation? Kind of like, what are these systems that are causing all of these headaches? Well, let's go back a little bit in time. So first, I want to talk about data warehouses. You're all probably familiar with some, in to some extent. But they sort of date back to the 80s and 90s. I think the term data warehouse was coined around 92. But they were purpose built to bridge the gap between operational data coming out of, like a standard Oracle style database, and business intelligence. So they were built for analytics. And the data types that they operate on are very structured. They're very clean. Data set, the schema is well known, and the way that the data is pulled in, data is aggregated from across a number of different databases. It's cleaned, it's maybe rolled up from event level to a day level, but there's some additional processing or pre-processing that's been done to it. And then in batches, that data is inserted into the data warehouse. And it's really good for sort of enforcing this consistency in terms of data quality, because you've got the strict schema. You're querying against this known set of dimensions. Everything is nice and sort of academic and pristine, and it's really good, and they're optimized for large queries. And typically the users of the data warehouse were, I'm calling them the business, but think about, any of the line of business owners or executives who want to know a couple of standard metrics. They want some standard reports about how the business is performing, whether that's revenue data, whether that's number of widgets sold over time, that sort of thing. One note here, data warehouses were not pulled from a single database. It could be, a bunch of different source databases, provided that the schemas all matched up. So it didn't require a one-to-one mapping between a transactional database and the data warehouse, but there is sort of this strict on-write schema. So data needs to be cleaned and organized and sort of transformed into whatever the schema was in the data warehouse. And another note here, you may have heard the term data mart. Sometimes folks use data mart and data warehouse interchangeably. A data mart is really an application specific or business context specific version of a data warehouse. It tends to be much smaller. They're tied to specific logical organization. And the example that I always give here is marketing specific data. So you may have all of your aggregates of campaigns that you ran, maybe some of the web analytics that tie into it, and customer segmentation that you've done over time. And that could be from across a bunch of different sources, but all of the marketing data is kind of pulled together in this one source. Now, historically, there have been two types of data warehouses, if we want to get kind of nerdy into the details of the background here. We've got the Inman model and the Kimball model. So Inman is called Enterprise Data Warehouse, somewhat incongruously. Kimball is also sometimes called Enterprise Data Warehouse. So clearly that's a differentiator between them. But kind of the key difference in terms of the two, to really kind of get to the nuts and bolts of it, are around the logical or physical separation of data marts from the data warehouse. So in both, you have your data sources, you've got some extract, transform, and load process that pulls the data out of your transactional database and into the data warehouse. And where the difference lies between the two is Inman is more of an ER model, and so it's not really well suited for direct analysis. But then the step that you take there is you create a bunch of data marts that are specific to a business context. They're physically separated, so they're in a different data warehouse, if you will. And then those are dimensionally organized so that they can be more easily queried. And then any BI tools or reporting applications hit those data marts directly. In the Kimball version, kind of this dimensional data warehouse, the model of the data warehouse itself is like a star schema where you've got fact and dimension tables or cubes. And then there's just a logical separation of data marts. So there is no additional step in kind of separating out the business context. You can effectively query the data warehouse directly. Now, nowadays, kind of with the rise of cloud native data warehouses, there's a little bit of a blurring of the lines here. There isn't that strict difference between Inman versus Kimball, and kind of everyone has some sort of hybrid approach. But I figured it was useful to go back kind of to the history and the background here. A couple of drawbacks with data warehouses. I mean, you can imagine they were pretty expensive. There was sort of dedicated hardware that you had to buy. It was a very specific skill set. All of the aggregation and the cleaning of the data was sort of a time-consuming process. And they're expensive because everything is done in batch mode in terms of the aggregation and loading of data. Data is frequently not fresh enough. And, keep in mind that this is something from the 80s and the 90s. No longer are we happy with the 24-hour turnaround time in terms of data. Like if an event happens, we want it in the analytics system as fast as humanly possible. And so a lot of the traditional data warehouses just aren't able to handle that. So they're a little bit clunky. They served a really great purpose, and I think they've been kind of a fantastic foundation to the way that we've done analytics, but they haven't really modernized well. The tech hasn't evolved. Anything like ML and AI has to be bolted on or done kind of in a post-processing where you're pulling data out in a different format, putting it in a location for data scientists and for those AI workloads. Now, one other thing that I want to point out here is because of that schema on write, where you're transforming the data and you're putting it in a very kind of specific way, you're making certain assumptions about the data that you want to have available to query. So they're perfect for known business context. They're not great for exploration of data. And that's really kind of where data lakes started to come in. They're more recent. I think the term data lake was coined in about 2010. I'm pretty sure that I was using data lakes before then, but the memory is hazy in my old age. So the core of the data lake is the purpose was we want data in its natural state of any type in its native format. Don't want to have to do any additional pre-processing. We want to be able to handle any type of data, whether it's structured, unstructured, coming in at various frequencies. We want it to just dump it into this wonderful lake of raw data so that we can do some exploration. So the goals were really around flexibility for multiple use cases, whether it was analytics, whether it was data science, although typically the users of a data lake are data scientists. And other info kind of background here, a lot of data lakes take advantage of open source software. So the software itself is pretty cheap. The storage mechanism, they're able to take advantage of some of the cheaper commodity hardware. So there was this push for data lakes because it was considered a cheaper way to store a whole bunch of data and have access to it. And because you don't have this schema on write, you don't have to force data into a particular structure or schema. It was considered highly configurable. So, for example, if you were a startup and you're adding in additional data sources and you might be pivoting and you want that super flexibility in terms of the data that you have, data lakes were very compelling because you needed to change the data set, great, add more, just kind of dump it in. Now, because data is so high volume in a data lake, SQL generally doesn't cut it. Also, because it's not structured, you may have videos or sound bites or things like that. And so programmatic access to the data became super important, which means then you have a different set of users who are accessing the data in different tools. So if we look at just a super simplified view of a data lake, we've got all of our business applications, databases, documents, all of our different data sources that are coming in. There may be some light ETL that's done on some of the operational databases, for example. But for the most part, data is stored in object storage. And then there needs to be some sort of catalog on top of that, so you know what data you even have available, maybe some tagging or some information about the data sets themselves, and then maybe you have replicated data that's for test cases, or for your models, something like that. On top of it, there's usually tooling around operations, data discovery, because that becomes super important. If you want to explore the data, you kind of need to know how to find it, and how to look for those patterns. And then governance. So it's very easy to create multiple copies of data within a data lake. How do you keep track of them? How do you make sure that you're not just sort of muddying the waters, pun intended, by creating additional copies, which then changes some of the patterns that you might be seeing in those data sets. Now, I mentioned that there's usually some programmatic way of getting the data out. This is where APIs or even some semblance of ETL happens here, because you need to process the data as it's coming out to get it into a format such that you can query it and such that you can do analytics. Another layer of processing that has to be done is sort of in this metadata storage layer. So say, for example, you have photos, you have videos, you're not going to get a ton of information about that other than, okay, it's about, this size, we know the timestamp of when it was created, we know what file format it is, but there's some additional, like vision AI that you can do to grab some features of that particular picture. All of that information can go into the metadata storage. So for example, you'll know if the image is of a person versus an animal or versus scenery, something like that, and that can be tagged and cataloged. Okay, so coming out of the ETL, this is what we call schema on read. So we're sort of formatting the data so we can read it kind of on the fly. And then that can be done via analytics tools or data science tools or in reporting or BI tools directly. In terms of where data lakes kind of struggle to find value, the lure was, hey, cheap hardware, open source software, it's going to be great, but data volumes have made it, them pretty expensive. Resource utilization can be pretty high. Overall total cost of ownership can be pretty high. There's a lot of scaling challenges and knowing what your capacity needs to be. And then I mentioned it earlier, but governance is really a big issue, especially if you need to take a slice of data to, as your test data set. I'm just going to take a slice and make a copy of it here or there. That leads to additional governance issues because of, little mini data silos, and you lose track of data freshness and really the provenance of it. And then also, because of the scaling challenges and the hardware challenges, there's a lot of you lose that nimbleness in terms of having to provision additional hardware. So definitely great for kind of the rise of data science, but they have data lakes kind of have their own drawbacks here. So a lot of companies are really faced with this data warehouse or data lake, which one do I choose? And it's not really an either or question, because they serve such different purposes. So kind of to recap, data warehouses are more at the terabyte scale. Data lakes can handle petabyte scale. It's just the volume is totally different. Data warehouses are great for a known context, known data. Data lakes are better for the unknown. You want to do that exploration. You want to look for patterns across the data without necessarily having that business context in mind. And so they do solve different purposes. And so while a lot of companies have had thought, well, which one do I need, a data lake or data warehouse? The general consensus was really, why not both, right? just have them all. And there really is no reason to have both. And a lot of companies do use the data lake as the repository of all the raw data. It kind of becomes that staging area. And then you segment an exploration pool and you make that available to your data science team. And then you have processing pipelines that refine and aggregate data into a data warehouse or a data mart, and you make that available to business users and kind of the BI tools. But once you start copying data into new sources, that again propagates pretty rapidly. You start to lose track of the lineage. And very rapidly you end up in this situation of like, what is the source of truth? And kind of where does it come from? This is sort of made even worse by within some of the data marts. What if you want to enrich with a third-party data source, then you have additional pipelines that you need to manage. So it creates this like proliferation of pipeline management that needs to happen. So for teams that are data engineering heavy, it becomes a prioritization issue. So if a line of business, let's say marketing, wants to add in third-party data sources, for retail propensity data, something like that. They want to enrich their data sets. Where do those pipelines get built? Who does it? How fast is it needed? And it can end up being sort of an organizational friction point. So really, what is holding everybody back in terms of progressing to sort of this new or a new pristine worldview in terms of data strategy? Really some key things. So overall data maturity of an organization, is the team skewed more heavily toward data analysts or data engineers? Where do the skill sets lie within the folks who work at the company? What kind of data culture do you have? Is the focus on centralization or decentralization of data? And then, and then the data silos themselves. So as an organization, are you thinking about multiple clouds? Do you want to diversify your tech portfolio, if you will, and have build outs across multiple clouds? Do you still have stuff on premise? Are you still trying to decommission data warehouses? So like, what does the data landscape physically look like? And then, how important is it to maintain a source of truth or deal with some of these quality issues in terms of having multiple sources of truth? And then the complexity of balancing these increasingly complex workloads and use cases with maybe some antiquated architecture. So there's a lot of things in play here for companies. But thinking about this from the technical perspective, there may be some obvious ways that we can start simplifying the stack and taking advantage of some of the technical advancements in the areas of, warehouses or just, tech in general. So that's where some of the platform architectures like data mesh and lakehouse start to come in. Now, when we talk about data mesh and lakehouse, again, it's not quite like two ends of the same spectrum. They solve different purposes. So it's not an either or scenario. It's not a zero-sum game, but they do solve different purposes. And so I know there's been a lot of buzzwords or just industry buzz about them, which is why I think it's super important that companies are very mindful about what they want to do here. So like I said, they solve two different purposes. Looking at Lakehouse, that one really, the goal is to enable data, kind of have the best of both worlds in terms of data warehouses and data lakes from a data perspective. And then on the data mesh side, it's enabling teams. So on the data lake side, the lakehouse sort of removes that overhead of the data, having a separate data lake and a data warehouse. Data warehouse starts to get some of the more flexible functionality of a data lake, and then the data lake itself gets some of the governance aspects of the data warehouse. So you get access to higher volumes of data. You get the schema on reads, so you don't have to do a lot of that pre-processing of data, and then you get a layer of governance on top of it. Now, on the data mesh side, it is all about putting the data in the hands of the people who know it best and have the business context. So if you think about different domain owners of data, they are the ones who are responsible for creating and publishing their data sets using whatever technology they want, providing sort of a standard API access for other teams to have that data, but it is decentralized data with federated governance. So the goal is to have, really well-defined, governed, discoverable data sets, but the management and creation of those data sets are held onto by the folks who know that data the best. Okay, going into data lakehouses a little bit. The goal is to have kind of centralized management, actually centralized data. So we're decoupling the data storage, and you might have object storage separate from structured storage. So this is where you start to take advantage of the data lake and data warehouse together. Effectively, it's all in one. And then in terms of the centralized management, you have unified permissions, you have kind of this overarching data catalog of what's available, which keeps track of your structured data as well as your unstructured data. And then kind of looking toward the top, you have your choice of processing tools, whatever sort of familiar or comfortable to you, and depending on what type of data you need to access. So if it's an analytics workload with SQL, you can access it, or if it's an analytics workload, you can access it with SQL. If it's AI/ML, you're wanting to use a more familiar notebook experience, and then there are also views that you can create of data in a very standard way, so that users have a consistent experience in terms of what that interaction looks like. So in the Google world, what our lakehouse building blocks would look like, and this isn't really, obviously it isn't an architecture diagram, it's more of a logical, but our if you think about the structured data storage, that's BigQuery, our cloud native data warehouse. And then more of the blob storage is Google Cloud Storage. So you can have all of the unstructured data you want. You can actually query from cloud storage via BigQuery. So logically, you can have access to all of that information kind of in one location. We have centralized management tools that let you manage, govern, kind of build this data catalog across your different storage mechanisms, and even create data lakes on the fly if you need to, for certain types of workloads. And then we have everything from Vertex AI, which is our AI workbench, SQL tools, streaming ingestion or pipeline tools like Dataflow, and then Dataproc, which is like a managed Spark, on top of these. So you have access to the data that you need when you need it in a consistent way. Looking at kind of the layers that get created, or one potential way of creating layers for a lakehouse, there's a few layers of processing that can happen here. So, over on the left, we've got all of our external data sources, kind of similar to what we saw in the earlier diagrams. And then you have some processing that's done, whether it's, just pure ingestion, or whether there's some additional transformation that's happening, kind of depending on the data sources. A raw or bronze layer of data. Some of that may be this is kind of all for structured data. And then you'll have views built on top of those tables. So these would provide, maybe data masking, some level of encryption so that you're hiding protected data, or views that are sort of optimized for specific analytics use cases, which then can be made available to a semantic layer and then out to whatever systems need them. In terms of the unstructured data, Google Cloud Storage, you can just dump everything in, and then some of that data can be pulled out and processed using things like additional data flow or ETL if needed, combined into a data warehouse style view, or a more of a materialized view on top of it. moving over to data mesh, I mentioned that it was more about empowering data teams and empowering people. So the goal here is distributed ownership. So the teams are really responsible for maintaining their data. They need to make it useful for others. They need to make sure that there's a sufficient amount of metadata available. And then there's sort of central governance and support for the platform. So thinking about it again from kind of an operational perspective, instead of spending most of their time on building the pipelines, you have, engineering can be focused on the governance tools. You have more data stewardship, making sure that all of that data is usable and has the correct lineage, so that the teams who need to actually interact with the data can do it on their own terms or with the context that they're familiar with. And so governance itself, so one of the key things with data mesh is building a data product. Every team builds its own product, and you have a product owner, you have a product consumer who's the one who downstream uses that, and then you have a data steward who kind of focuses on the governance and what it looks like. So there are a few core tenets around the data products that really help to scale this governance. That data is generated within a domain. So for example, marketing or sales or finance, every domain manages that data as a product. And then there's sort of these key roles that I mentioned where you have the product owner, you have the steward, so that you've got folks who are dedicated to ensuring that the data is useful to other teams. And then we have, with each data product is owned by a particular team, but your tech can be centralized or decentralized. And the goals here are, to be able to measure the value of the data, that teams are really empowered to generate value, and they have a little bit of flexibility in terms of the tech that they can use. There's no central bottleneck. So if it's important to bring in a third-party data set for enrichment, they're not bottlenecked by some centralized team, and they're not trying to fight against priorities from other lines of business. But one of the key pieces here is that every domain, each of these teams, and really you can think of them as lines of business, has to be empowered with the right skills and knowledge to be successful. So this really means a significant organizational shift, so that, for example, within your marketing team, you need to have folks in the marketing team who have data engineering backgrounds, who have data science backgrounds, who have data analytics backgrounds, not just business analysts. So there's definitely a shift in the way that data is treated. And it needs to be something that's thought about very carefully across the organization. It is not a tech answer. It is an architecture, a tech paradigm, if you will, with very, very real organizational change behind it. So here's an example of what a data mesh might look like. So over here on the bottom left, we have producers, and we've got a couple of examples of what individual data domains look like. The top one may be marketing data. The bottom one may be, I don't know, an additional data science team or something like that. But they've got inventory data that's coming from, or let's say it's, operations management or something, but you've got your operational data that's coming in, it's getting, translated into or stored in BigQuery, and it's curated, maybe enriched with additional data sets. But then there's an interface that's created on top of it. The data is made available through an exchange to the consumers. And the consumers could be an analytics team, it could be the IT team, it could be, I don't know, somebody else across the organization. But they have access to the data sets that they need. They can do whatever processing that they need to. Similarly with domain 2, maybe they have a different setup, their own stack for the processing that they need. But then there are very clear interfaces for the consumers to access the data from domain 2. Across the top, there are some consistent access control, so identity and access management rules, policies that are set up by a data management or governance layer, and then workload management. And in BigQuery, that would be reservations and slots. Similarly, there are discovery tools. So data catalog, where you can kind of look at the set of data sources that you have by metadata. And then, maybe there's additional views into the data that are in Workspace, or different ways to access it. But generally, that's kind of what that architecture would look like, where each domain has its own little mini stack. And the data is refined into a way that makes the most sense for that specific domain, but then is queryable by a large portion of the organization. The third architecture that I want to talk about is really like a variant of a data warehouse methodology. So it's a little bit different than a lake house or a data mesh. It's very, very data warehouse specific. So it was created to solve the challenge around maintaining and evolving large data warehouse projects. And in particular, the situation where you have data that is evolving over time and your data model needs to change and new data sources need to be added. So with a data warehouse, that's very tricky to do because you've got, a very strict structure to it. So the data vault is additive, and it's designed to be kind of resilient to change because you're just adding to it over time, and you're explicitly separating some of the structural information from the descriptive attributes. So the design is really to enable parallel loading as much as possible, so that you've got really large implementations and you can scale anytime you add data sources without kind of having to restructure the whole thing. The data vault model layer is normally used to store data, and it's not really optimized for query performance. So there's a very specific use cases for this. In terms of the modeling, there are 3 entity types. So you've got the hub, it's this business object, and it kind of separates out the business keys from the rest of the model, which means that it doesn't really need to change over time. The link stores the relationship between hubs, kind of using those business keys, and then satellites store the context. So the hubs and the links form the structure of the model, but they don't have any temporal attributes, and they hold none of the description. So all of the contextual data is stored in the satellites. And so the example that we have here is airlines and airports. So the airline is a business object. It's modeled as a hub. It doesn't contain any specific airline data, only load date and the data source. You can always kind of track back to the beginning, and it offers a view into the lineage. So here's kind of what the different architectures could look like. We have a staging layer that does not apply any changes to the data. So it sort of provides a temporary area, supports the process of moving data from different sources into the data warehouse. The raw vault stores the data in a model built around the identification of the business keys in those data sources. So this supports new data sources or schema changes in the existing sources without requiring any sort of modifications. So the goal is to have like strict auditability requirements. This is great for really a regulatory environment or company that has a lot of compliance rules. The business vault is built from the raw vault, so it retains the hub, link, and satellite structure, and then applies transformations on top of it that conform the data to whatever business rules that you have. So to that extent, you're kind of creating a curated data source on top of it. This can be built from like materialized views if needed, and those can be rebuilt over time. So kind of that separation is actually key to the data vault, that you've got raw vault, which is scalable ingestion, and then the business vault is how you handle the evolving business requirements. And then there's a presentation layer on top of it, which is the information Mart, and that's requirements driven, scope driven, or scope specific subsets of data, again, that is more of like views into specific business context. And so you kind of have to map things back together. So those are kind of the 3 data architectures that we talk about frequently with customers. Really, the next question that I get is like, where do I start? As I mentioned, none of these are really on a strict spectrum, and it's not just a technical question that you need to answer. Any one of these data models or data architectures requires some tech, some process, and some people changes, whether it's additional skill sets so that folks who are used to a data warehouse have to learn more engineering to be able to interact with the data lake or lake house. Whether you're putting more control over data within the hands of people as opposed to a centralized team, but there's that interplay on tech, people, and process. And all data platform changes and data strategy changes do require organizational change. Some of them perhaps more so than others. So for example, data mesh, it's a hot topic. We hear about it from customers all the time. I get a lot of questions around like, how do I build one? It sounds great. Where do I sign up? But the thing is, it's not a push button implementation. It requires a significant level of buy-in from stakeholders across the organization. And it has some significant impact on both the upstream producers of the data that's ingested, and then downstream consumers of the data. So it's something that really needs to be done deliberately and mindfully. Also, it's super important to start any sort of strategic conversations around data pretty early. Frequently, I see what should be a strategic decision get replaced with a very tactical one, because these take a lot of time. And if you're still on-prem and you're dealing with software licenses and hardware renewals, you really have to plan far enough in advance for that inevitability. So whereas a company may really want to take a more strategic view of data, they've got this looming deadline, and either they're making the tactical decision to have a drop-in replacement for a cloud native data warehouse, or they just kick the can down the road and don't make the decision at all. So it takes time to research, to plan for, and to implement a lot of the new data strategies. It needs to be done with a lot of care and consideration, and frankly, enough time to make a long-term decision. And the tactical decisions are why there's all this additional technical debt, and it's just going to keep accruing over time and just keeps kicking the problem of the data strategy down the road. All right, that is it for me. I have a whole list of further reading for you if you're so inclined and need something to put you to sleep at night. Over the last year, my colleagues and I have put out a whole lot of white papers and blogs on the convergence of data lakes and data warehouses, building data engineering organizations from the ground up, figuring out what kind of data processing organization you are. All of these are publicly available. I can make these slides available to you all if you're interested. And maybe you'll learn a thing or two or be interested in some of the data strategy.
Yes, we would like you to make the slides available. And the way that we'll do it, on our event pages, the same pages that you all logged into to join the event. In a few days, once I process the video and the slide share, I'll link them up there. So you'll be able to rewatch this, share it with your colleagues and friends that weren't able to join, and you'll be able to dig through the slides and hit all those links. I think I've come across some of those blogs in the past. Definitely interesting content, and it's not the type of content that is hard to get into. It's very approachable. So if you're brand new into the data architecture space, you should still. You don't have to be a Python guru or a math guru or anything to get in and still understand the concepts there.
Yep.
All right. Yeah. Thanks, Susan. I did notice some messages in the Q&A chat. So the way I like to do these is I'll read them so that on the recording, because in the recording the chat doesn't show up on the recording. So I'll read them out, and then have you take a shot at them. And if you just make something up. No, it's fine if you don't have a for these. All right. So scrolling up, this is from Ramji. What I'm finding out is for companies to build a multitude of products and services, a central data warehouse, data lake, or data garden seems to not function well. So I guess it's having a lot of many of those things. Your experiences or thoughts on that observation?
Yeah, I think that makes sense. I mean, a lot of companies are a lot bigger than they were, and you've got multiple lines of business. Thinking about Procter and Gamble, for example, there's their entire CPG. They've got a number of different lines of products and beauty, and they're different, cater to different audiences. Unilever might be the same way. So yeah, having a central data store doesn't really make a ton of sense, in part because it would be massive, in part because each of those lines of business is really run separately. But what you need to be able to do is have I guess, first of all, from a data strategy perspective, how much does that data need to be shared across? And is it a view into data that is that needs to be shared? That's a different problem to solve than we need to make this blanket bucket of data available to everybody. So one is sort of that top-down decision in terms of how much do we share between the organizational lines of business. And if it's just a free-for-all, that's awesome. There are ways to maybe logically segment that, but physically have it in a larger single location. Within BigQuery, I mean, you can have it as different project IDs, different billing IDs, even if you need to really segment it. But generally, I would recommend to keep some level of separation, create views that can be stored or that can be shared across organizations.
All right. Yeah, the Ramji does have some follow-ups, so we'll go with that, and then we'll go to Brent's question.
Yeah.
The second, well, we'll jump to the to my question number one, which we just asked. Data mesh seems to be the solution. I do agree. DNA skills seem to be an impediment across the enterprise, especially. Yeah, do you see data mesh as a data mesh? Did I say data mesh? Data mesh.
Yeah, I mean, so I guess the risk with data mesh is that it just becomes a data mess. But yes, I think something like a data mesh would be a solution. Again, that comes to the question of what amount of that data do you want to share. If you put it within the organizational boundaries, who kind of know the business context of the data, then you've got, one makeup company sharing certain metrics, with the soap company and stuff like that. Yes, you can totally do that, but you're right. It is difficult to get the buy-in organizationally, kind of from the parent company, to have the right set of skills, and it may require a fair number of reorgs within the team. So it works. The other thing is data mesh is not all or nothing. It's actually over time you can create it. So you can even have little mini meshes to start and kind of drive buy-in across organizations that way.
All right. Yeah. So even though the point of view that it would be great to have one solution that solves everything, there might be so many different use cases, whether they're use cases bounded by privacy or use cases bound by geography, where it's simpler to, instead of having just one big implement, having kind of a mesh for its own purpose, where it's well known who it's being shared with.
And that's a great point too, in that in the way that I view it is data mesh is sort of like agile, where you have the original sort of academic view into agile, and we've got the ThoughtWorks paper by Ajamak with a very specific view of data mesh. But The actual implementation at a given company is going to be, select the bits and pieces that make the most sense for you. Just like you never get the purely academic view of Agile. There's always some normal form that makes the most sense. So you kind of, it's a buffet. You take what works for you, and the rest you just sort of walk past.
Yeah, I was just going to get into an Agile joke. Yeah, we used to do, a long time ago, we used to do programming. And it's not even a joke, but where you'd have one person type, the other guy watches. If you modify that, you could have one guy left hand, the other guy right hand, and see what you can type.
Yeah,
it was good.
Yeah, no.
Have the split brain problem. On the so Ramji has a secondly question. The problems we want to solve with data always seem inadequate with the tools that are available at the time. Even today with BigQuery, we are finding limitations with row size, which forces us to do more processing and less than optimal product architecture. Do you see, is that similar to your experience in what you're working on? Sometimes go ahead.
Yeah, no, it does come up on occasion. If you're running into constraints or limitations with BigQuery specifically, we should probably talk. There are some new tools out for things like query optimization, slot estimation, because words are hard now. But your account team can certainly help you with that. I want to make sure that there's not sort of a one-time change that we can help you make in terms of architecture to help facilitate some of the processing. But definitely reach out and we can help you, whether it's, query optimization, architecture optimization, or cost optimization.
Okay. Yeah. So like many things, if you're running into a problem with a Google service, don't just suffer with it. Reach out and work with the support team and the product team to see what maybe there's something that because it's impossible for everybody to know everything. Maybe they know something that's an easy fix or can work with you on something. All right, and Ramji says, thank you, Susan. On the grant, looks like he has a Kubernetes type of a question. And yeah, so people are moving to say like 12-factor applications where this isn't part of the question, but I'm interpreting it. 12-factor applications where we're really focused on things that are not around for a long time. And on Kubernetes, they have the concept of persistent data or transient data. How that type of shift in applications and data storage, does that affect the data warehouse world the way that you're in what you've seen, or are they kind of two separate concerns?
I haven't encountered it much, but just because I haven't doesn't mean that it's not something that comes up. So I answer to your question, I don't know. I haven't seen it. My focus has been more on the data processing and the pure analytics side. But maybe,
yeah, maybe.
I don't have an answer there.
Yeah.
Sorry, I don't have an answer.
Yeah, that's fine. I have just one technical question, and if you still have questions, please type them more. On the looking at the placemats, the proposed architectures, and with people having petabytes and zettabytes of data and whatever bytes of data comes after that, are you finding that? And we know that the cloud and people are like multi-region. Are you finding that people try and get all their region, or they're keeping it in separate pockets? Because with zettabytes of data, if I have it all in one place and have another complete copy, it seems like I'd be using a lot of data. Is there any pattern that you're seeing that people are doing with their setups?
It really depends. Sorry, that's going to be the answer, I think, to everything. It's like, it depends.
Yeah.
But a lot of it is, dependent on any of the compliance or regulatory issues that they're dealing
Sure.
with. So if there's regional specific constraints there. But yeah, I mean, there's a lot of use of multi-region. And I'll admit it does become problematic from a capacity standpoint for us, making sure that we have sufficient capacity in each region. I haven't seen any specific patterns.
Okay, and that's fair. Yeah, it probably definitely comes down to it. It depends, and one of the depends is money do you have to have duplicates laying around?
Yeah.
Easy follow-up, like what is a day-to-day Susan's day at work look like? Like area of focus, things that you're working on. I think Ramji might have missed the first. He was on a outage call or something like that.
Yeah, so I'll outage call. I hope not. But there's it's okay, Ramji. I'm sorry. So I am a product manager that sits across our data analytics suite of products. So I'm not tied to any one product, but I do sit kind of across the data analytics world. So that includes everything from, PubSub, Dataflow, Dataproc, Dataplex, BigQuery, Data Fusion, kind of like the whole shebang. And my work, I'm focused on. I've done a lot of the thought leadership work in terms of our views on our stances on things like lakehouses, data mesh, et cetera. I work a lot on overarching product strategy. So what is the I'm a miss know-it-all. Yeah, that's me. But I do work on product strategy. So what is our suite of products together trying to do? How are we positioned in the market? Competitive intelligence, all the way through to building demo environments for our customer engineering team. As well as go-to-market planning for specific launches. So I'm a bit of a jack of all trades.
All right, yeah, thanks for that, Susan. And just we'll close with one final question. It's not purely, maybe not even a technical one. It's about it's more of a career question. So if you could go back in time and talk to younger Susan, is there any advice that you'd give to younger Susan that would make your life easier now?
Yeah, there's a lot in hindsight, right? Like, oh, well, yeah, actually what I was doing back in the day was data engineering. We just didn't call it that. It was I think I would go back and say to the Susan who was a software developer but complained that she was always the one who ended up trolling through the huge data sets that we had looking for patterns. That there's actually a career there. And don't just complain about the person who ends up doing all of the analysis of data. Like, that's actually a very valuable role. But perhaps that's very specific to like 2005 Susan. But that the cross-functional is super important. There's always value in the unknown, so looking for the patterns and looking for the relationships that among people, among data sets, is super valuable. And the other thing is, at the end of the day, a lot of the fundamentals around data science and data mining are exactly the same now as they were 20 years ago. So the tools have changed, but all of the fundamentals are still there. So your knowledge will still apply, even if you don't stay up to date on the latest libraries.
All right. Definitely appreciate you taking your time to talk to us today, Susan. we'll get the video out within a few days, and they'll be on the event page, so you can everybody can rewatch them, share them with your. And we do have every last Wednesday of the month. We do have other speakers. So if you find topics that you're interested in, I think since you signed up, I think you might get notifications. Who knows? I forget how the system works, but definitely really appreciate it. Thank you, Susan, for spending the time with us today.
Yeah, thank you so much. This was a lot of fun, and I appreciate the opportunity.
All right, and what we'll do now, I'll throw up a 5-minute timer. We'll just take a quick break, and then whoever wants to stick around, we'll do some virtual networking after that. And if we don't see you in the virtual, take care, appreciate it, and stay in touch.
All right. Thanks, everybody. Cheers.